Buoyancy and stability. Buoyancy and stability are key factors that ship engineers and builders focus on when designing all sea-going vessels. Stability refers to a ship's ability to remain upright and resist capsizing even when external forces like high waves, strong winds, or storms create conditions to tilt or capsize the vessel. Ships can also tilt during loading and unloading of cargo at ports due to human errors. Ships achieve stability through a balance of forces and design elements focused on a low center of gravity and a properly designed hull shape to balance between center of gravity and center of buoyancy. This is ABHA, and this lesson explains key factors in ship stability. Stability. Most people believe that when a ship is on water, it will always float the right side up. However, a ship can only float with only its hull in water without fear of tilting if it is built according to the required standards at the shipyard. Every ship at sea has to face many forces of nature that will try to turn it over and capsize it. Therefore, the ship must be built to resist these forces by using factors that create stability. Too much stability can cause unpleasant motions and become costly due to high fuel consumption. Too little stability will make the ship heel over easily and capsize. To maintain stability and reach a state of equilibrium, buoyancy and gravity must be equal. A body is in a state of equilibrium when the result of all the forces that act on it is zero, and the resultant moment of the forces is also zero. If a body faces a small disturbance from a state of equilibrium and returns to that state, it has positive stability, which means it is in a state of equilibrium. If the disturbance reduces the equilibrium even more, then the body has negative stability or is in a state of unstable equilibrium. Unless a ship is stable, it will not float upright because although in the upright position it is in equilibrium, there will be disturbances from the sea, air, and movement within the ship which will try to force it out of the upright position. Ballast. Ballast plays a vital role in enhancing a ship's stability by controlling its weight distribution and center of gravity. Ballast, in the form of water, rocks, or heavy material, is placed in a ship's ballast tanks or lower compartments, which adds weight to the bottom of the ship, ensuring it does not become top heavy, which could make it capsize. By adding weight to the ship's lower sections, ballast lowers the center of gravity, and a lower center of gravity makes the ship more stable and increases its ability to resist tilting or rolling on its side. There are four main factors that determine a ship's stability. Center of gravity. The center of gravity is based on the ship's weight distribution, including cargo, fuel, and other loads. A low center of gravity is created when a ship's weight is distributed with ballast water or other heavy material in the lower part of the hull, which helps prevent the ship from tilting. Center of buoyancy. The center of buoyancy represents the volume of water displaced by the ship. Center of buoyancy is the point where the upward buoyant force acts and aligns with the center of gravity to ensure stability. Metacentric height. Metacentric height is the distance between the ship's center of gravity and the point where the buoyant force acts when the ship tilts slightly. The larger the metacentric height, the more stable the ship is. Hull design. Hull design is the shape of the hull, which is very important for stability. A wide hull increases stability, while a narrow hull lacks stability for speed and maneuverability. The circumstances that can upset both buoyancy and stability and cause a ship to heel may be external or internal. External forces could be the action of the wind affecting the high freeboards and the large superstructures of the ship, causing increased wind resistance, which can affect the maneuverability and fuel efficiency of the ship. External forces can also be the outside action of waves that cause rolling, pitching, heaving, surging, swaying, and yawing of a vessel in rough seas. Density and salinity in water can also affect stability. Density mainly depends upon temperature and the salinity in the water. Salinity in seawater varies from area to area, and many objects that will float in the Dead Sea will sink in fresh water. Internal influences mostly relate to the human factor, HF, such as a stowage plan error caused by the navigational crew in loading and unloading cargo, which can make the ship heel over to port or starboard side. Stability can also be affected when the ship is maneuvered incorrectly and the action of the rudder causes the ship to heel on one side.